So the next method that I'm going to talk about is epoxidation. Using peroxy carboxylic acid. The best and the first, not best, sorry, the first peroxy carboxylic acid that was synthesized don't forget peroxide bond. That's why they are calling them peroxy carboxylic acid. The very first peroxy carboxylic acid that was synthesized was methachloroperoxybenzoic acid. You don't want to spell that. Okay, guys. Commonly it is known as MCPBA, methachloroperoxycarboxylic acid. So when we react this compound with carbon double bond, when we are reacting this with carbon double bond, we will get the carboxylic acid itself. Okay, so we are extracting the peroxy oxygen, guys. So how does this reaction work? So I have to tell you, MCPBA was the very first one. And again, when you see here, anything you see, it means solvent. Guys, so I want to be over. Because all chemical reactions occur in solvent. So I am using a generic also I will remind you that I am not showing the stereochemistry of your epoxide for obvious reason, because it would go from either side if there is not a steric imbalance. This is one. Second, obviously oxygen, both bonds are going to be from same side. It could not be possible that these two bonds to be trans. Would it be possible, guys? So that's why I'm not showing a stereochemistry. So how it works? Don't forget, the chemistry of carbon-carbon pi bond is electrophilic addition. Always starts with an electrophile. So this time, what is the electrophile order? You heard me, I told you we are going to extract the peroxide oxygen. So, from general chemistry, we are familiar with certain things as hydrogen bonding. If you have oxygen and you have hydrogen that is bonded either to oxygen or nitrogen, you expect hydrogen. This is one. Second, from CHE 118A, we learned 5-member ring, 6-member ring are Mother Nature's favorite cyclic interaction. I don't know if the diagram that I have drawn gives you a kind of idea that they have cyclic interaction or not. I hope you are paying attention. Basically, this atom is electron deficient for obvious reason. So the direction of electrons are in this way. So this is going to be your electrophoron, guys, this oxygen. Because the nature of carbon-carbon pi bond is electrophilic addition. So what will happen? It is all a cycle of electron. Your pi bond is taking this hydrogen because it is already. Your other pi bond is giving electron to oxygen, which it is your electrophoron. So you are giving electron with one hand, you are getting it back with the other. Now that being said, again we all understand oxygen, nitrogen, carbon, all of these elements that they are in the second row. Maximum they can have how many valence electrons? In compounds, maximum how many? 8. They never ever can go over 8. Even oxygen, even fluorine, they cannot go over 8. So what will happen? Obviously, when you are taking the electron away, here, this carbon becomes electron deficient. This oxygen cannot have. So all is going to be a cycle of electrons that they are going around. That's why your peroxy acid becomes a regular carboxylic acid base. And the oxygen of peroxy is going to be inserted. Physically, you can see that oxygen is being inserted between the two vinyl carbons. Now, why epoxides are so popular, other than being used as epoxide, they have lots of use. What are the use of epoxides? Formation of vicinal diol. Vicinal means what, guys? Two atoms bonded. When I say vicinal diol, what do I mean? The two neighboring carbons have OH. They are alcohol. So, in lab, that we are trying to make natural products to be more specific carbohydrates. Because carbohydrates are molecules that we have 2 or more OH group bonded to vicinal carbons. So naturally, these epoxides are useful in making diols. So next, the reason synthesis of N-type vicinal diols. Epoxides are being used to make N-type always. The two OH groups are in N-type position. When it comes to epoxides, you can add water in epoxides in either acidic medium or basic medium. And don't forget, water by itself is not reactive. So either in acidic medium or basic medium, you can add water always anti-vicinal diode. The two OH are 180 degrees apart. Always anti. So we will look at the mechanism to see why that's the case. So first, mechanism in acidic medium. This is what I am looking at. I'm going to ask you guys, what would you expect first? What would be the first step? Acid-base reaction. There is one reaction in chemistry you cannot stop. It is possible. And that's acid-base reaction, which in this case, obviously, it is possible. So, step one, acid-base reaction. Don't forget that. This is going to be the most unstable oxonium ion you could ever have. It is remembering, and oxygen is positively charged. So what will happen then? It doesn't matter that you do not have a good nucleophile. And don't forget, when the leading group is present, the nucleophile always attacks from the opposite side. Now, that being said, before doing this, so the reason I wrote that, I want you see, from the very beginning, anytime, guys, anytime you open any ring opening, always is in what manner? Ring opening always is anti. Ring opening is always anti-addition. So I want you to know that. So it's not that you and I decide, and I will explain. I said this is the most unstable positively charged oxygen that you can have. In this case, I can have a secondary cation. So because it is very unstable, I will go ahead and pour my cation.